see if it is working. Yes, that's working. Minimum square error, as you can see, that's our line. Multivariate linear regression. In this lecture, we will learn how to fit data sets in a linear function, which is called, this concept is called linear regression. First of all, we have some modules to import, such as NumPy, Pandas, Matplotlib library, and we will use sklearn. So from sklearn, we are using those classes, datasets, linear model, model selection, and metrics. The file, I have already downloaded it. So here I'm going to open and read this file from pandas. Name of this file, weather underscore features. And I want to observe only I want to observe only 10 rows of my data. So this is how my data looks like. Consider the city Madrid. So let's see the data again, how it looks like. So only city I have is Madrid. Now I would like to make a forecasting about the temperature. Let's say I want to use humidity. So my X value is data humidity, and my Y value is going to be data temp. So right now I'm going to use model selection. I'll have two different data sets. One is training data set, the other one is testing data set. So this from model selection, train and test selection function. So this function returns us a tuple with 4 elements. That's why this is how we unpack this tuple from model selection dot train test split. So my X value, my whole data is X, and I would like to, my target value, test size is 0.2. That means that the data is gonna be splitted, and 80% of the data is going to be training data set, and the 20% of the data is going to be testing data set. So right now we will use linear model classifier over here. So let's say regression equal to linear model dot linear regression. Now reg is an object of linear model class, and in this class we use fit function. Inside fit function we use the data set we would like to fit, which is X train and Y train. We have to be sure that X is a data frame, otherwise it's gonna give an error. As you can see, now it works. When you include two brackets, it means that this is a data frame. Otherwise, it is just a series, and all these classes and the functions just accepts data frame. So I converted X to a data frame. It looks like that's working, and now we want to see what is the linear function is in a form of ix plus b. We would like to observe what a is. For this, we just say reg.coef, which is this number. And if you would like to observe intercept, which is value b, we just put reg.intercept, and that's all. Now I would like to see how our testing data is doing with this formula. So now I am going to use predict function, and I'm going to insert x test data. And now let's see if it is working. Yes, that's working. And then what I would like to see, print minimum square error is equal to, now we are going to use metrics dot mean squared error, and now I am passing prediction and the real test values. So other thing I would like to see is r square value, r2 value, and then again from metrics r2 score. All right, our mean square error is 32 and r2 value 0.4 almost. So this shows that if r2 value is small, then it means that this is not a good predictor, this function. Also, let's draw some graphs. For example, when we because we said we're importing matplotlib as plt, so when we say plt dot scatter and our x test and y test values, this is how it looks like. So let's add some labels. plt.x label, our x label is humidity. Let's say humidity level, and our y label is temperature. So to be able to draw our line, our regression line, we use plt.plot, and inside we use x test and the predicted value, the line itself. So I think line is blue, so let's change the color to red. As you can see, that's our line. It's not a bad, it doesn't look like a bad prediction, but I think the data spreads a lot. But it looks like the correlation between humidity level and the temperature is high. Let's use another. So let's check our data again. Data dot head. Let's see 10 values. So what else we can use? Let's say we're gonna use both pressure and humidity to predict the temperature. So for this one, now I'm going to use two factors to predict temperature. So I have two factors now. Let's observe x. Yes, that's working. And now the y value is same. I'm going to pass. I'm going to do the same steps. All right, it's working. Linear regression, multivariate linear regression. And again, I will observe exact same steps. This time, this is a little bit better predictor. The new, these are like A1 and A2. Right now, multivariate linear regression works like A1 dot x1 plus A2 x2 plus b. As you can see, we have two different coefficients, but we have one intercept. So this is how we apply multivariate linear regression model.